While we wait on other folks, should we do just sort of like a very quick round of introduction? Because I do see a whole host of new faces here.
Sounds good. Want to kick us off, Seven?
Yeah, hi. I'm Savin. I'm one of the maintainers of the Metaflow project and co-founder, CTO here at Outer Bounds.
All right, I can go next. My name is Nissan. I work on the core Metaflow team at Netflix. I am co-hosting these office hours along with Seven.
All right, I guess I could get next. I thought Roman would go. But my name's Faraz. I'm currently at Doordash and will be presenting along Sunset. So, Sunset, do you want to introduce yourself? Oh, you're muted, I think.
Hi, I'm Songze. I'm also from Doordash machine learning platform team. I'm mostly working on serving. We're currently working incorporating Metaflow with serving dev experience.
Say hi.
Oh, hi, I'm Roman. I work on Metaflow.
Yeah, and folks on the call, if anybody wants to introduce themselves, feel free to. Otherwise, we can get started with the meeting.
Yeah, I mean, if no one else wants to go, it's going to be a relatively brief agenda, I think, for office hours today, and hopefully we'll have a lot of time for a discussion. But basically, want to go over the reasons why DoorDash went with Metaflow, the high-level architecture of how we integrated Metaflow into our ML platform stack, and then we'll also go over or suggest some topics for discussion that have come up recently on the DoorDash side. Feel free to ask questions throughout. We could make this like a more interactive session. Yeah. And also, this is going to be a recruiting call. DoorDash is hiring for the ML platform team. We have positions available, including for senior and staff positions. So careers at DoorDash.com. Tell them Faraz sent you. It won't help you at all, but maybe they send you a bonus, maybe they don't. I don't know. But again, careers at DoorDash.com, machine learning platform team. Yeah. So yeah, going into why Metaflow, right? And it comes down to like three overarching reasons, right? So we want a unified and extensible experience. We needed something to abstract the underlying compute infrastructure for our MLEs. One thing to note about ML projects is the line between production and development is, very nuanced, I guess, is one way to put it. A lot of times, when you're training a model, it's in dev until it's like not, right? Like basically you promote something to production after the fact, right? Like if you run a training flow and you like the metrics, it's not like you want to rerun that exact same training flow in production again for it to count. You really just want to promote what was in development to production, right? And that entails running at production scale, even while in dev. And finally, reproducibility, right? It's one word, but it means a lot of things. And this is very critical when it comes to development flows as they relate to machine learning. And there's additional complexity just because of the inherent non-determinism, right? So kind of just going a little bit deeper onto each of those, right? Like, why does having a unified UX, in particular with a public API map, right? So from the MLE perspective, and in this case, MLE's machine learning engineer, Other places might refer to them as data scientists, algorithm engineers, a lot of different titles for a similar role. But basically from the users of the platform, right? The ML practitioners, the people who are actually training the models and deploying them into production. It's a lower cognitive overhead, right? So as they move from feature engineering to training to serving and so on and so forth, they're uh, working with a very standard UX, right? So things are built in the same way. It's a lot easier for them to get started, right? And move forward. It also means they're no longer blocked on the platform, right? So it's probably everybody on this call is well aware, right? ML, particularly in the last couple of years, has been moving at like a very rapid clip. It's very hard to keep up with every single trend. Some might not even pan out, some will pan out. But at the end of the day, you don't want to be the bottleneck for your organization, right? So if you have a kind of open source based API, it means that MLAs could actually pull in open source technologies more readily, and they don't have to wait for platform to bless it in a certain way, right? Like with Metaflow, people have published a lot of different plugins. There's a Ray plugin, there's a Torch Run plugin, and so on and so forth, right? If you want to use any of those plugins, it's not a massive lift for you to do like a pip install, and as long as it conforms to the plugin contract that's supported by Metaflow, you could go on ahead and use it and not worry about it breaking in the future, right? So from switching to like the ML platform perspective, right, and borrowing a little bit from the Netflix terminology, highly aligned, loosely coupled. Like, what does that mean? For Doordash, the ML platform team is actually globally distributed, right? So not just we have people, I think, in every time zone in the US, but also like we have people in the EU, right? So how can we make sure that we're building a cohesive platform without having to constantly jump on a call with each other and have a lot of synchronous communication, right? So if we standardize on a kind of single way of building things, right? Like again, kind of looking at the plugin based architecture offered by Metaflow, we could stay highly aligned. So if like the training team builds something, I think an example I'll show later on is the image decorator, which mints Docker images basically, right? If the training team builds it, it could still be used by serving, right? And it's again built in the same way. So that allows us to kind of stay highly aligned, but at the same time, nobody from the training team really had to talk directly to the serving team. It just kind of worked, right? Uh, Another point is vendor onboarding, right? So when you have something that is based in open source, it's a lot easier to also run proof of concepts with vendors, right? So you could publish how they could interact with your platform, right? Point them to the open source repo, ask them to build the integration based off that, and then you could easily incorporate that, right? And kind of taking those together, vendor onboarding and also MLEs being able to unblock themselves, allows the ML platform to be a lot more directed in their focus. So we could build for more long-term initiatives and not have to constantly jump or switch contexts. Everything making sense so far? Going back to the second point in terms of prod scale, right? So ML development, by its nature, it is ad hoc, right? Like kicking off training jobs. If you're trying to do like hyperparameter tuning, you're testing out different architectures, different features. It heavily depends on specialized compute, which is somewhat a departure from maybe traditional software engineering, where like the main focus was like actually running on commodity, like very commoditized hardware. But in the case of like ML development, not only does like how many GPUs, but like what type of GPUs. Like the GPU architecture also has an impact, right? You also probably need higher memory machines, right? And it's very iterative and experimental, obviously, right? You don't actually know what will work before you try it out for the most part, which is, again, a departure from maybe more traditional software where it's probably frowned upon to, I don't know, like do like 12 iterations of the same thing and then testing it out in like production, right? It's it's less deterministic in that way. And all that means is you do have to run at prod scale, right? You do have to kick off large scale training jobs, computing like I guess like for supervised machine learning, creating the training table, which could uh, include like months of data or even years of data. You do need to kind of run that at full scale, as opposed to just like taking a small sample, right? And finally, like the biggest point, maybe reproducibility, right? And you know, I try to kind of summarize what is meant by that in one sentence here. The ability to reliably and consistently rerun the same workflow, different execution environments, different times, different users, but still get the same or comparable results, right? And what does that mean? Like if I run a train workflow end to end, right? And then a week later, Sungza or Savin run the same workflow, they should more or less generate the same model within the margin there, right? And then when I kind of take that and run it in maybe like a different namespace, whether it's like the production namespace, if I run it on Kubernetes versus like launch it via Argo workflows, it should still be the same, right? And that comes down to four main components, right? So dependency management. Here you actually see us using the one of our custom decorators at image. And this basically takes the base image and then installs the specified Python packages and mints a new image based off that. And that image is cached, so anytime another step, regardless of which workflow it belongs to, will actually reuse that same image, right? So that kind of handles the reproducibility in terms of the exact packages that are used. Metadata persistence is also important for reproducing ML workflows, right? So, taking the hyperparameter tuning example, you want to know, I don't know, like for tree-based models, the tree depth, or like, the dropout ratio that was used to generate the final results, right? And then finally, code persistence. This is where we we overlap a little bit with more traditional software development, right? Like, but the difference is for software development, kind of code persistence is like the be all end all, right? And running in isolation, right? So if we're running the same flow concurrently, we don't want to step on each other or impact each other's workflows. Cool. So those are like the big reasons why we chose Metaflow. I didn't go over any of the Metaflow details because I'm assuming everybody's already familiar with how Metaflow works, how the metadata persistent works, etc. But any questions based off that so far? Cool. I'll just try to get through these relatively quickly. In terms of architecture overview, it's very simple. I'm sure probably most people who have used Metaflow will probably be more or less aware of this. But basically, we do depend on Argo workflows and Kubernetes. We also have other compute providers that we leverage. You could think of this like running Spark jobs. You might use Databricks. You might use EMR. There might be GPU providers as well that you might want to leverage. But for the most part, it still uses like a KA pod as a jump-off point to launch those workflows. And then we back, we have like some sort of blob storage for the metadata store. This could be S3, this could be GS, etc. Right? Yeah, and in terms of resource management, we do leverage Q. So this runs on as part of our Kubernetes cluster. And basically each team within Doordash has their own namespace. Each namespace has its own queue with a designated amount of resources, including like for different GPU types, overall memory, CPU, etc. And these queues could actually borrow from each other. So let's say team A has 100 A10 GPUs, right, and as their nominal quota, right, or resource quota, that they need to use 150. Assuming Team B has the capacity to spare, they could actually just borrow it from Team B as long as it's not being used. So this is how we kind of limit and share resources across the various different teams. At DoorDash, we have probably over a dozen different orgs that have their own budget and resource requirements, as well as different secrets that they need to manage. So this is how we are able to scale company-wide. A little bit of a closer look at how namespaces are set up. You can limit namespace access with octagroups or whatever authentication system you have at your company. You could set different object and resource limits, and these are easily overridable. So to make it self-serve, so the amount of work that the platform has to do is really just kind of create like the base template, and others could easily override it for their own use. One different thing that we might be doing at DoorDash with respect to Argo workflows is how we replicate event messages. Like I mentioned, each team has their own Kubernetes namespace. That means, sorry, was there a question? No. Yeah, that each team has their own Kubernetes namespace, but some teams do depend on each other, right? So if a workflow finishes, that might actually need to trigger a workflow in a different namespace. So we do replicate all the events to every single namespace. And Sunza will kind of talk about how that integrates into our serving layer.
Yeah, so currently we're building a new serving infrastructure for the whole MLE teams at DoorDash. So this is basically the workflow like we're using currently for MLE to deploy a serving workload. And with help of Metaflow, like MLE just need to maintain a Python script with Metaflow Argo workflow definitions. So there are several steps needed for deploy a serving workflow. The first, we need like model artifacts. Second, we need to define like machine resources like CPU, GPU, number of hours, and auto scaling policy. And third, I think we need define some dependencies if there's some Python workload, which probably needs some image build process. And also there's some deployment related steps needed, like before deployment, for example, like the networks, service mesh, UI. Also, we need to trigger the splitting pipelines. So all of these steps are defined in one Python script with help of Metaflow. So and then with this unified interface, the MLE can deploy to whether they can choose to deploy to dev environment or production environment with a single unified interface. And all of these are from local computers. So compared to before, that MLE need to go to different places for these steps. And currently, I think with this experience, really elevate the experience for the MLEs at Doordash for deploying a certain workload. And also, I think reproducibility is also a huge advantage after we integrate with Metaflow. So currently, each deployment will have their own version and could be reproduced like with a single Python script. And this Python script could be triggered on local laptop. So MLE, I think we're really trying to make the MLE life much more easier than before. Yeah, next step.
Cool. Any questions on that? I know this is like a relatively large chart, but I'm unable to zoom in more.
I had a question on what is the registration? You have a couple of registration steps here. So what do you do in those steps, and what do you use?
Yeah, we have basically a model registry, and it's basically just an API call. We also cache some of that into our configuration management system because the QPS we get online is very high. So we need a way to efficiently pull information about a model, like for example, what features it depends on for feature fetching in a very efficient manner, right? We can't really depend on like another standard gRPC call because we're talking about like millions of QPS.
When the dev model gets copied to production, it looks like, how does that get updated in the registry?
It's more or less a change in the flag. You could think of it that basically the dev model is in a different bucket in S3, and then it essentially just gets duplicated into the production bucket, right? The production bucket is more locked down, so not everybody could write to it, whereas the dev bucket, any kind of MLE has permissions to write to it. We also kind of do some other persistence in terms of like metadata, so that we're able to reproduce any dev model that gets promoted to production.
And that metadata is duplicated as part of the copy operation?
Not so much as duplicated, but basically we just want to make sure that we still have the code provenance. Right now it doesn't do this, but the idea is that it'll actually back it up into GitHub as opposed to right now, which Metaflow just backs it up to S3. That we want it to be like more discoverable, particularly if somebody's dealing with an on-call issue. We don't want them to go through like S3 or necessarily have to run like Metaflow specific commands. We just want it to be more visible and available.
And as part of the model, I think you mentioned something about like the features and the code artifacts, like maybe there's some preprocessors, encoders that are attached to the model. Those are also part of the copy operation.
So like pre-processing and post-processing, and maybe Sangza could talk a little bit more about this, but we leverage Trident, and basically that's essentially packaged as part of the same model within the same pipeline.
Yeah, Triton has the capability to do the model ensemble. So basically, another layer of the Python code, like in all included together with the smart artifact. So we upload all of these to S3 and register it to the model store.
Got it.
So kind of a follow-up question on that. So like I guess the recipe to assemble all these things, because I'm guessing that if you're training in the Metaflow pipeline and some of your models are stored maybe as artifacts, so like how do you kind of export, or like how do you have the user define what they need to export as, like, okay, this is the pre-processing one or step or stuff like that? Like how, I don't know if that question makes sense, but yeah, like if you go from stuff that you're storing as Metaflow artifacts to something that you're dumping in a bucket as a model, like, is that a step that you guys provide? Is that something that the MLEs have to write?
That's part of the registration step, as well as, I don't know if we have this in a separate, but there's like a model prepare step that packages it as well. So we provide some, you can think of it as helper functions that essentially publish the model as well as deployment spec. And then based off that, they could kind of deploy it to production.
Okay, so this is something that you guys as the platform provide, and do you support, like, I guess you support a subset of the models that, or like you support a subset of model types, or just like
Yeah.
how does that? Okay.
Yeah. So you can imagine there is a path for the ensemble models, and then the customer just need to define what is the model and what is the pre-processing, post-processing. And then the Metaflow would prepare the model with the structure a Triton need and upload to that.
And is that Python prepared structure, like, do you test that before you upload it, or there's another separate workflow that does the testing?
Testing could be done, like you can deploy first, like deploy into that environment and do the test. And also we can have some we call dev box. So like you can run your Triton locally, like before you do any deployment.
Okay, so that copy to production is not automatic, like it happens after
Yeah,
all the
no,
testing.
it's all defined in the Python script.
Okay.
And you can run this Python script while deploy to dev or that.
Yeah, so I guess like another thing is things are deployed in isolation, right? So even if you go ahead and you deploy it to production, it's kind of in its own pod, so it won't really impact anything else. You can, like, just for the purposes of speed, because a production deploy does take quite a bit longer, you can launch essentially a dev remote instance and just kind of query that and see if it works if you want like a kind of rapid feedback. I think we also have a separate kind of Argo workflows pipeline built via Metaflow that does like some performance testing that you could run against production, or I guess like the production environment. Yeah.
How do you handle the configurations for dev versus prod? I'm assuming there's different, like,
Yeah, so
settings.
we have a routing layer in front of everything, right? So for dev, it wouldn't touch the router, right? Whereas for kind of production calls, everything will go through the router, and the router will send it to the correct uh, model deployment.
Okay.
Overall, I don't think it's too different from how like Metaflow hosting works to some degree. The main difference is that we have kind of more integration with the feature store, and there's a concept of uh, um, how we handle routing is a little bit different.
Mm-hmm.
Any other questions? If not, we had like some topics we wanted to bring to the community, I guess. Three come to mind. One is, integrating feature engineering into the whole Metaflow ecosystem. In particular, like without essentially building another ETL framework. I'm sure like every company has like 6 ETL frameworks that they're currently maintaining. We don't necessarily want to build another one, but at the same time, uh, to have a true kind of end-to-end development experience for ML on Metaflow, you need to have some level of integration with feature engineering as well as generating the training and test tables and data sets. The other topic is around kind of cost attribution and management. We kind of touched a little bit on this in our presentation, which is how we divided up teams into different namespaces, and that makes it a bit more straightforward to calculate costs and subsequently manage them. And the final topic is related to the Metaflow UI, but maybe this is better discussed in a Slack thread, particularly in terms of understanding how caching works and kind of optimizing it as we scale up. So I guess out of the 3 topics, which one holds the most interest for the community?
I'd be interested in the ETL stuff.
Nice. That's the one I want to talk about. Any other opinions? Yeah, so for the ETL stuff, I don't have like much in terms of slides, but we had like some early thoughts, I think. Let's see, oops, sorry, stop sharing. Let me share this again. Yeah, so like one approach is to go with like a decorator approach where you define like a feature set. Maybe you want to also have a way of defining dependencies. That you could think of this as almost like I don't know, a SQL query. Um, that I don't know, like how does Netflix currently leverage Metaflow for something like this in terms of feature engineering, or is that mostly handled upstream?
Right now, we unfortunately don't have much, I think. I mean, but it's something that we've been thinking about. Either someone had mentioned, like, I guess, like you, like basically having the step have a SQL statement and then effectively having a way to annotate it saying, hey, this needs to run on, some Spark node or something like that.
Mm.
But lately, we've also been investigating whether we integrate with feature stores directly.
Mm.
So we haven't, we don't have much. I'm actually curious, like, do you guys have a feature store that you integrate with directly? And
Yeah. Yeah, we do have our own feature store that we started building some integration with. Right now, the only integration we have is updating. The definition still happens outside of Metaflow. So you define your kind of feature definition, right? And that includes like the type, the upstream dependencies, etc., right? But then you're allowed to actually update it from your Metaflow flow. And it just has to conform to the same feature type, right? So, if you defined it as a float, you can't write like a categorical feature or something like that, right? But it's a little bit, uh, I would say bespoke at the moment, right? It's not fully integrated. And if you look at it from the perspective of the MLE, you still have to be aware of two different systems, right? Like you have to go define the feature and essentially create like a pipeline there. But then if you want to use Metaflow to maybe update more frequently or based off specific triggers that are kind of more easily defined, in our case, the feature store doesn't have a lot of flexibility in terms of when you trigger the run, right? And the way it works for offline batch features, you basically update the offline feature store first, and then on a set schedule, there's a you know background process managed by the platform that uploads it to our online feature store. Which is either like Redis or some form of RocksDB.
And so are you looking to effectively figure out how to define a feature computation in Metaflow and then kind of push that to your feature store? Would that be like an ideal end state?
Yeah, that's part of it. So like a few things come to mind. Like one with anything related to uh, feature definitions, like backfills are basically a first class citizen, right? They run fairly frequently, right? So if you make like maybe like a small change, you need to backfill like 30 days worth of data, maybe 6 months worth of data, like relatively large backfill jobs, right? So how do we support that? Another is around lineage, which like Metaflow has some tools to solve, but they're not quite as uh, mature as like in other places, and you basically kind of hand it off to like the scheduler at that point, right? Like if you want to kick off a 30-day backfill, you'd probably use like the Airflow integration to more easily do that, right? Rather than something directly within Metaflow. So kind of having a way to define that like source lineage and be able to easily kick off the backfill is another. And then like finally is like the integration with the feature store, right? And maybe like you don't define like the full feature set within Metaflow, and all you define is like the final training table, which uh, might depend on a bunch of upstream tables and will allow you to do some basic transformations. But that's it. But it is something that we are kind of discussing and planning for. So if you guys are open to collaboration there, definitely something we could explore further, and I could connect you with some folks on the Doordash side.
Definitely something we're looking at. So yeah,
Yeah, I guess like Salman, with kind of like the other customers of Metaflow or Outer Bounds, how do you see them leveraging Metaflow for the feature engineering aspect? Salman, you're muted if you're talking. That's the danger of sneaking away. Sometimes you get called on. But yeah, I think like a lot of follow-ups on that. We could have like an entire hours long discussion on it. So maybe we'll schedule a follow-up with you, Roman and Nissan, with a couple folks from our side. I think that would be very helpful to just kind of brainstorm together.
Yep, sounds good.
Yeah, and maybe open source. Cool. Any other topics or questions the group has? If not, I'm just gonna close out on this slide one more time. Careers@doordash.com for open roles. and you get to work with fabulous people like Sansa. So I'm just gonna leave that there. But yeah, if nothing else, thanks for the time, everybody. Hopefully this was useful.
Yeah, thanks a lot for presenting for us.
All right.
Thanks.
Bye all.
See you, folks.